Okay, we finally got the light. I wanted to record this like yesterday during nighttime, but I couldn't. I was really tired. I'm sorry. So, and yes, today I have everything. Yes, I have my laptop. If you're wondering, I'll show you this. You know what? Lap. It's AMD Ryzen AI 7 and integrated Radeon graphics. Both AMD, not Intel and Nvidia. But still, both of them are good, so I don't care. Honestly. So Lenovo's. If you go on Lenovo's website, there's 60% off on websites. What? Don't tell me. I just got this like it's not okay. It's not this one. No, please remove this. If laptops. This isn't, no. It's, on website, I think it's marked up at like 89 something ish. I don't exactly remember the price of this on websites. Yeah. AI PCs. It's not a PC, honestly, it's a laptop. I don't know if it's gonna, oh, okay, it shows up. It's the, yeah, this one. It's a 87, it's basically just 88,000. I got it for like 80. Yeah, so yeah. It's a good laptop. I've been using it for like a week now. Not even week. Okay, but okay. Like 3-4 days. I've been using it. It's honestly a good laptop. Battery backup, it's great. You know, I was playing CS:GO on this. CS:GO 2. I got it off Steam. I don't know. I'm not a big, PC gamer. I will become one eventually. Of course, AMD Radeon. I've already told you guys about it. 8060M. It's 24 gigs of DDR5s and 1 terabyte of storage. So it's good. Display. It's 14 inches. It's a non-touch HDR5 with 400 nits, 60 hertz, 65 watt power supplying, charging ish. It's a black backlit Luna gray. So yeah, 1 year warranty, Luna gray. Yeah, it's an idea about resolution. If you want, you can get it. If your budget allows, honestly. This is my first laptop that I've ever. Okay, this is the first one. So yeah. Okay. Aside from all this, now let's get to the actual business. Why we are here. I think I should, push this back a bit so there's more room. It's charging or not? Oh my god, I plugged it in, but it's not charging. I didn't. I'm stupid. Here. Good now, I think. I think it's good now. Oh, is it? It's good, right? Okay, charging. We're just gonna let it be. Yeah, I got this study light. I told you it's gonna be up there. I think visually now it's gonna be much better. Like if you can. Oh, I need to pick up the camera. Wait. Yeah. Visually, I think it's much better. Yeah. My hands look still ugly, but not as much. Bruh. Okay, I'll stop. Okay. Okay. Yeah. Okay. Here. Oh, okay. We were at the Photo 51. We did that. Now we were at the double helix. Okay. Now I have a laptop, so I don't need to draw. I can just show you guys here. Let's just open going DNA's double helix structure. I'll show you guys a good diagram of this. Oh, this was the one I was talking about, like in the previous part. Which the Trumans. This was the. It was similar to this, just a bit more, tiny bit more prettier, but yeah. View image. Oh, don't. You can just what copy image, open image in new tab. Okay, we can zoom on it or not. Don't visual search it. I'm also new to this. Okay, we can. This isn't very detailed, but yeah, I just wanted to show you guys, like, this was the structure I was talking about previously. Let's get a detailed one, like a detailed structure. A detailed diagram. I want something simple for you guys to understand and me to explain. Like, I don't want a diagram like this, you know. Menu tab. Let's just look at, you know, let's just look at it. Just see. This is like super detailed. And even I don't know much about it, because I'm not a PhD holder, or I'm not working in genetics. Okay. I'm also same age as you guys, so yeah. Let's where? Which one should it be? This one, I think it's good. Why? I hate Microsoft. I'm kidding, I love Microsoft. Don't. Man, eventually I'll get a sponsorship from like Microsoft. So I need to have a good relationship with. Just kidding. But why did it? I'm stupid. I told you to. Open image in new tab. Why is it downloading instead of? It's constantly downloading it. So yeah. See. We know. Okay. Yeah, a bit more for you guys. You can go on Google and follow up with this. So if you see here, you can see these pentose sugar structures that they have provided. I'll, you know, see, I'm talking about these. These are the pentose sugar structures. This is the DNA, if you don't know. Okay, this is what DNA looks like. Now what it, okay. So, and you know DNA has double helix. So this one section is called a helical turn. And that's 10.5 base pairs per turn. And it's a helix pitch. Like right here. It's confusing, okay? It's really confusing. And it's in angstrom, so 35.7 angstroms. If you want, you can just note it down. A helix diameter, you know what a diameter is. Basically a chord, the longest chord of a circle running from the center. That's diameter. So, same concept. This from one end to the other, that length, that's called the helix diameter because it's one helix. That's why it's called a helix diameter. That's 20 angstroms. One angstrom is 10 raised to the power minus 10. If you don't know. These are connected by nitrogenous bases, adenine and thymine, and guanine and cytosine. Adenine and thymine have double hydrogen bonds, while guanine and cytosine have 3 hydrogen bonds between them. And here is axis rise. If you multiply, I think it contains a particular number. Yeah. Previously, I wasn't even talking about, like, there should be a particular number of base pairs present in a turn. So that number is 10.5. That's it. That's, I think, that just covers up the entire structure of DNA. I might even get a DNA model kit. I might. Okay. Now back to notebook. Just wait. Where's the... Let me get my biology and theory book from the back. Yeah. You don't need to write everything. Just understand. You'll get the notes. You can make your own notes. You can make your own beautiful notes. So we did do the Evans-Chargaff's ratio, and we did discuss the double helix. We did discuss the Frederick mixture. You know, the person who discovered the DNA. He didn't call it DNA, he called it a nucleon. Now we are gonna discuss the base pairing. First, the unique property of two the polynucleotides. They are complementary to each other, and they're the sequence of the bases in the one strand is known. Then the sequence in the other strand can be predicted. Okay, what they are basically talking about is, for example, I'm talking about this paragraph. Keep your NCERT with you, guys. Yeah, this paragraph. So, here. So what happens is, oh my god, my Parker. It's in shambles. I like dropped it. Wait a minute. Okay. We're good now. Okay. So in this paragraph, what they are saying is for DNA consists of two strands. Okay. 3 dash 5 dash 3 dash 5 dash here. Okay. Complementary. Now they are saying that, for example, if we only know these strands, like there's adenine, there is thymine, then there's again adenine, then there's guanine, again guanine, then there's a cytosine, and then there is a thymine. Okay, that's what they're saying. Now they're saying that they're complementary to each other, so we know adenine makes double hydrogen bonds with thymine, and cytosine makes triple with guanine. We know that. Or am I stupid and I'm saying the wrong thing? Is it? Okay. So even if we don't know about these ones, question mark, we don't know about this, we don't know about this side. So what we can do is adenine makes with thymine, thymine makes with adenine, adenine makes with thymine, guanine makes with cytosine, guanine makes with cytosine, cytosine makes with guanine, thymine makes with adenine. So now we know. So these two are complementary to each other. So both strands can act as a template. Either this can be a template, and this can also be a template for making the daughter DNA. You know, both can act as a template for the formation of daughter DNA. Daughter DNA. Okay? That's what this paragraph is saying. If you read, if each of the strands, let's call the parental DNA as a template for the synthesis of the new strand, the two that's called the daughter DNA that's produced would be identical to the parental DNA molecule. Because of them, these implication of the DNA should become very clear. Both will be same. It doesn't matter if this is being utilized as a template. It doesn't matter then, and if this is being utilized as a template, it doesn't matter. Both will give out the same result. Okay, the daughter DNA won't have any different. They will be identical. Okay, enough. Now the salient features of the double helix. So we need to go to notebook because we need to note it down. Yeah, the tripod, I've ordered it. It will arrive like tomorrow, so I'll get it, and we're going to be stuck at a really awkward angle. Yeah, I like my setup now. It's sort of complete. I won't stay here. Okay, so first feature. It is made up of two polynucleotide chains where the backbone is constituted of sugar phosphate and the base project inside. We've already talked about this, sort of in an indirect manner. What they're saying is, in the first one, they're saying, what they're saying is that DNA, the double helix structure, okay, so it's made up of two polynucleotide chains. These are the polynucleotide chains, okay, made up of two. This is a polynucleotide chain. Should I write it? Nucleotide chain. And okay, these two are polynucleotide chains, and where the backbone is consists. These polynucleotide chains are made up of what? Nucleotides. Okay, what are nucleotides made up of? What is this substance on this? I don't get it. I need to order one of these again. I'll get another Amazon Basics touchpad. Sugar and phosphate. Sugar, which is deoxyribose. Mention that in bracket. Deoxyribose, and it's made up of phosphate. And phosphate's also there. Okay, this is the backbone. That's what they're referring to. That's the backbone. After that, they have said that the base should project inside. That's common sense. They are projecting inside. These nitrogenous bases, that's what the notation is. Just remember, when I'm writing NB, that means nitrogenous bases. It's a long spelling. I don't want to write it again and again and again, because we will discuss about it. The two chains have anti-parallel polarity. Again, we have discussed it. One end is going to be 3-, 5-, then another one will be antipolar. So on the 5- side, it's going to be 3-, and on the 3- side, it's going to be 5-. Okay, so they have anti-parallel polarity. This chain goes from 5- to 3-, while this chain goes from 3- to 5-. See, 3- to 5-, 5- to 3-. 3, 5, 3, 5 on the above side. Okay, the bases in the two strand up here, the two hydrogen bonding, I've already told you guys about it, forming the base pairs. Adenine forms two hydrogen bonds with thymine, I've already told you, from the opposite strand, and vice versa. Similarly, both guanine and cytosine with 3 hydrogen bonds, resulting always purines comes opposite to pyrimidines. I still don't know the exact pronunciation. This generates approximately uniform distance between the two of the strands. Okay, that's it. We have already discussed it. They are basically saying adenine makes 2 hydrogen bonds. These are hydrogen bonds. Okay, hydrogen bond. Adenine, thymine, cytosine, and guanine. Okay, triple. Now the fourth one. Fourth one is the two are coiled in a right-handed fashion. The pitch of the helix is 3.4. Let me pull up the image. God, what? Thank you. Yeah. The helix pitch. See? The helix pitch. It's 3.4 nanometers. They have put it as 35.7 angstrom approximation. And this measurement is in nanometers, that's in angstrom. And if you don't know, nanometer is 10 raised to the power minus 9, while angstrom is 10 raised to the power minus 10. So they have converted this data in there. They have converted it. Okay. Billion 10 raised to the power minus 9. There are roughly 10 base pairs in each. One helix turn contains how many? 10.5 base pairs per turn. That's what they are saying. So I've already taught you guys most of the stuff present in this silent features. Turn consecutive. The distance between the base pair in a helix is approximately 0.34 nanometers. How much is the axis rise? 3.4 angstroms. It's in 0.34 nanometers. If I convert it, it's going to be 3.4 angstroms. See, it's just they have converted the entire thing into angstrom. That's how we were taught in school. That's how I was taught in school. Yeah, just a couple of months back we discussed it in school. So yeah. So yeah, done for. That's yeah, fourth one. The plane of one base pair stacks over the other and double helix. This, in the addition to hydrogen bond, converts the stability of the helical structure. Well, this one confuses me too, because I can't visualize this. What they are saying, I still don't get it. What I understand from this, the plane of one base pair stacks over the other. So they're talking about they are basically talking about this base pair is stacked over this is stacked over this. That's how it is. Okay, they are stacked over each other, so that contributes to additional hydrogen bonding, which makes the helical structure even more stable. That's what I get from it. Okay, I don't exactly know, but that's what I get from the line. Now we are at the central dogma. For this, let's just take reference. Let's just take a reference book. Okay, now it's gonna be okay. Yeah, Central Dogma by Francis Crick. There were 3 central dogmas. Oh God, my earbuds. Oh God. These are my first pairs that I've ever gotten. I don't like earbuds, but my head's too large, so headphones, especially like I've used headphones that cost like 2,000 rupees at max. So yeah, 2,000, 2,500. So the top part, it just breaks. I don't know why. It has happened like 2 times. A few years back I got a headset from Boat. Didn't like it very much. And recently got one from Hammer. Didn't like. Yeah, they were good. They looked cool. They were good, but yeah, they broke too. My head's too large, man. I'm not even kidding. My skull's like really big, so I do need like quality headphones. I'm thinking of getting Sony. Like they cost like 8,000, 9,000 something ish. But yeah. Dr. Mike said 2 things you should invest in: a good, comfortable chair, a night lamp. Sorry, 3. A good night lamp, and quality noise cancellation headphones. But don't listen to them over what? 60%. 60% at max. What am I doing? Here. There's gonna be Baltimore, Commoner. And then there's Crick. It must be. It should be here. Wait, the correct section, right? Genetics and evolution. See, oh, M-Boy. Yeah, you can look at this. It's much more detailed. There's major group, there's minors, there's the axis rise, one helix, hydrogen bond, sugar phosphate, bases. And yeah, this was the sugar structure I was talking about. Then they have talked about the different types of RNAs. Here's the central dogma. I told you there are 3 central dogmas. The okay, I'll write down. So sorry, wait a minute. One-way flow of information was given by Crick. H. Temin and Baltimore gave the concept of reverse central dogma. What we study in here in the in the NCERT is the central dogma given by Crick. It's a single flow. But here, reverse transcription also takes place. I've already told you guys about the retroviruses. They have RNA as their genetic material. They undergo reverse transcription when they are in host cells, and they convert the RNA into DNA, and that's where replication takes place, and that's how they infect. Did you get that point, guys? Come on. Okay. I'll keep it on my tie. Okay. So, DNA to RNA to protein. Okay? This is one-way flow. Alright, transcription. Just note that the term, I'll explain the terms. Then there is translation. Okay. Then there is replication. Okay. This was given by who? Crick. In what year? 1958. Crick gave this. After that, Commoner gave the circular flow. There is DNA, there's RNA, there is then, RNA is here too, then there is protein. So, it's in a circular loop. This is the circular, I'll write the heading, central dogma. Okay? Circular flow. Given by Commoner. In what year? 1968. It's an additional topic. If you want, you can just skip. It doesn't matter. Well, this one is important. That's why during retroviruses, people get confused, because they never studied about this. There is the process of reverse transcription, but it just makes things much more easier. It takes hardly 5 minutes. Come on. Protein. This was given by who? H. Temin and Baltimore. I don't remember the year, I do remember the name. 1917. I ruined it. Great. There is replication that happens. There is transcription that happens. There is reverse transcription that happens. Okay. Reverse transcription, and then there is translation. Okay. This was given by Crick. That's what we study. This was given by Commoner. We don't study that. This was given by H. Temin in Baltimore. It's a good thing to know the scientist's name. I have a good recall, so I do remember the names. I'm not flexing, I'm just saying, okay? Don't come after me. Oh my god, you're just flexing. And it's not a flex, okay? It makes life much harder. See, they even gave the line. Now there is packing of DNA helix. So either we can just skip this and come back to this after, because this is not related at all what we are going to study after this. It's not related, it's just completely different. There is RNA world, there is machinery of enzyme transcription, then there is two types of transcription that happens in prokaryotes and eukaryotes. See, this is the eukaryotes one, this is the prokaryotes one. Different factors are involved. Rho factor, sigma factor initiates it, rho factor just stops it. Yeah, tailing, capping. There's a good mnemonic here that I'll tell you guys about. Mnemonic makes your life so much easier. This part, the genetic code, this is the thing that's just, it's really, really difficult to understand. It took me a while, okay, because this one, like here, this part, the permutation combination part, this one, yeah, it's hard. It was hard. This wasn't even the hardest part. I did find it much easier to understand. But after this, the Hergobic Corona and the several Okio enzyme, that was, man, that's rough. There is the frame shift insertion, deletion, mutation, translation. Then there is the lac-operon. Why we call it lac-operon is because of lactase is involved. If another lactase acts as a, what we call it, inducer. Wait. Inducer induces. It's a substrate. It's a substrate for the enzyme beta-galactoside regulates in the absence of a proper. I don't exactly know. I need to study again. This is the most hated. I hate this. I'm not going to teach you guys the Human Genome Project. What you need to do is go in here, go on YouTube. Okay, I'm telling you what you need to do for Human Genome Project. Just go and just scroll. That's what you need to do. I'm not even kidding. Why am I getting so many weird recommendations? Okay. Who likes Dexter Morgan here? Tell me, who likes Dexter? I'm gonna show you my search history. My mom also uses the same account, so yeah. Oh, well, what? Okay, thank you. Thank you so much. Oh, wow. I'll make a separate video. I'll tell you guys about the good channels. Wait. Which counts? I'm gonna blur this part. Okay, I'm kidding. I'm not gonna blur this part. Well, these accounts are not mine, so what were yeah, human genome. Human Genome Project. Go in here. You can watch this video. Dead education, great. Well, National Human Genome. This is also, I think, good for you guys. You can go and study. Animations are like really good, and I recommend you guys to actually, go and watch animations, because that's how I learned. Mayo Clinic, of course. Of course, we need to go visit Mayo Clinic, of course.
I think I know I had a heart problem when I was about 4 years old. I remember.
Oh God, no, come on. Oh God, well, why?
And then
Stop,
I would turn blue.
stop, please.
Everyone in my family.
For God's sake, thank God. Okay, that's enough for today. I'm not even teaching guys properly. These demo lectures suck. I need to up my game. I'm not gonna even edit it. I'm just gonna leave it just as is. I'm gonna just upload it.